Welcome back to solving radical inequalities. We're going to do two more examples in this video. We're going to go a little bit faster through these two examples. So now I've got the fourth root of x plus 1 is less than 3. Our first step, looking at the domain. When I look at the domain of this problem, I see that I have an even index, so the radicand must be positive. So that gives me x plus 1 is greater than or equal to 0, x is greater than or equal to negative 1. This domain, I'm going to go straight to my number line, and I'm going to mark out to the left of negative 1. Those values are impossible because they are outside of my domain, or when I plug values less than negative 1 in, I can't get a fourth root, so this statement can't be true or false. It just doesn't make sense. Now I'm going to go through solving this. I'm going to make an equation, solve algebraically. Fourth root of x plus 1 is equal to 3. Fourth root of x plus 1 is equal to 2. Raise each side to the fourth power. X plus 1 is equal to 16. 2, 4, 8, 16. X is equal to 15. 15 is associated with this inequality symbol, so it's going to have an open circle. So I don't know if what's going to happen with 15, but it will have an open circle. Negative 1 is associated with my domain restriction. So if I do have solutions in this region, it will be a closed circle. So now I'm going to check a couple values. I'm going to check 0 and I'm going to check 80. I'm picking values that I can use that are going to be nice. I'm not just going to pick a random number. I'm going to pick nice numbers. Nice numbers are important when we get to some of the harder problems. So x equals 0. The fourth root of 0 plus 1 is 1. Plus 1 is less than 3. Well, that's just 1 plus 1. 2 is less than 3. And I said that this negative 1 was associated with the domain, which has a greater than or equal to, so that's going to have a shaded circle. 15 is going to have an open circle, and I'm going to shade in here. I now need to check 80 to see if I've got solutions over here. So x is equal to 80 is going to be the fourth root of 80 plus 1. Plus 1 is equal to 3. The fourth root of 81 plus 1, right, the fourth root of 81, 3, 9, 27, 81. This is going to be 3. And remember, it's a principal root, so it's positive. Oops, this should be less than. I'm checking the inequality. Is 4 less than 3? No, so that's not part of my solution. So my solution is negative 1 included to 15 not included. Remember, negative 1 is associated with the domain and 15 is associated with my original problem type. For our next example, I'm looking at the square root of 2x plus 2 plus 1 is greater than 5. I'm going to start by looking at my domain. That's my first step. This is an even index, so the radicand must be positive. 2x plus 2 must be greater than or equal to 0. And that ends up giving me x is greater than or equal to negative 1. This is my domain. I must include this. So I'm going to mark negative 1 on my number line, and I'm going to cross out to the left. Okay, so now I'm going to turn this into an equation, and I'm going to solve it. Square root of 2x plus 2 plus 1 is equal to 5. Now I will square both sides to get rid of the square root. If I'm going too fast, feel free to pause the video or slow it down, back it up. So when I solve this, I end up getting x is equal to 7. So I'm going to mark 7 on here. 7 is associated with my original inequality, so 7 would have an open circle. Negative 1 is associated with my domain, so it would have a shaded circle. I'm going to check values in each region. I'm going to check values that will be nice. I see that if I plug 1 in here, I'm going to get a perfect square, so I like that. And same thing will happen if I check 17. So here are my checks. Remember, we need to go through the checks for the factor line analysis. Factor line analysis requires us to check points in each region. So if I check x is equal to 1, I get the square root of 2 times 1 plus 2, that's the square root of 4, plus 1 is greater than 5. 2 plus 1 is greater than 5. That is not true. So that region will not be part of my solution. If I check x is equal to 17, all right, I get the square root of 2 times 17 is 34 plus 2, plus 1 is greater than 5. Square root of 36 plus 1 is greater than 5. 7 is greater than 5. That is a true statement, so this gets a smiley face. -1 isn't part of my solution region, so I'm not going to include it. 7 gets an open circle, and I'm going to shade to the right. So my solution to this problem is 7 to positive infinity.